Welcome back. In the last video, we finished off by talking about some yield curves. So the yield curve you're looking at right now was the last one we looked at. This yield curve plots the spot rates based on time to maturity, and in this case, we actually had yield rates on the half year. So we finished off teasing that that we can read the economic expectations of the market, sometimes at least, in the yield curve. So let's see what we mean by that. So we're going to start by saying the yield curves we looked at last time are what are called normal yield curves. They're increasing. So let's scroll down to the next question. Right? So, all right, the observations we made about yield curves describe normal yield curves. They're increasing. Why would we expect to see normal yield curves? Well, that's because the longer an investment is, the more risk, right? Given a longer amount of time, there's more possibilities for inflation, more possibilities for non-payment, and more possibilities for the unexpected, right? Which you can't at all even imagine, right? In addition, remember way back in chapter 1, we talked about interest, like a risk-free interest rate, as capturing deferred consumption. So a longer investment means you're deferring your consumption for longer. So you expect higher compensation. So for all of those reasons, under ordinary, reasonable economic conditions, we expect to see a normal yield curve. But they're not always normal. So this example shows an inverted yield curve. So this is actual data from the Treasury Department based on the market on August 2nd, 2019. So here's our yield curve. Now I do need to caution you, the direction is fine, but please note, first of all, the x-axis is not scaled. So this is the spot rate for 3 months, 6 months, 1 year. So this same space is 3 months, this space is 6 months, right? Then 2 years, 3 years, 5 years. So so that's one problem with this graph. The other is that the y-axis doesn't go down to 0, so that means vertical differences may be exaggerated. Nevertheless, the direction of the yield curve, and the reason that is because I had trouble getting R to do my bidding, and to get R to do that, that's why. Maybe sometime I'll make a better graph. But nevertheless, the direction is not changed, right? Just the severity, the horizontal and vertical effects are distorted, but the direction, the fact that this is a decreasing yield curve, doesn't change. And therefore, we had an inverted yield curve. And this was, on August 2nd, 2019, the first inversion of a U.S. yield curve since 2007. So that's why it's interesting. So what's important about, what does an inverted yield curve say? That's the bottom line here. So for all my stumblings about the inadequacy of this graph, here's what it tells us. It tells us that, it basically tells us that the market thinks short-term investments are riskier than long-term investments, which is a signal that there may be expectations of some economic trouble in the near term, specifically something like a recession. Right? That's the reason, the macroeconomic expectation. Right? So a yield curve signals a recession may be coming, at least that's what the market expects, because it indicates that short-term risk is riskier than long-term. That said, shortly thereafter, the yield curve went back to a normal curve, and we did not, in fact, have a recession. So just because you see an inverted yield curve doesn't mean it's coming. It means the market thinks it's coming because something's happened. With a normal yield curve, we expect normal economic conditions, a modest amount of growth, relatively low unemployment, relatively low inflation. The Federal Reserve, who is in charge of monetary policy in the United States, typically tries to adjust various inputs into the economy in ways that inflation should be between about 1.5% and 2% per year, right, which would be low inflation. There's also a flat yield curve. Right? So here's an example of a flat yield curve with all spot rates flat at 2%. All of our work so far has assumed a flat yield curve. In other words, we've used a constant interest rate. Later in chapters 11 and 12, we're also going to continue to assume a flat yield curve with occasional exceptions. Like you can do some of the things in chapter 11 with any yield curve. but the computations get nasty, and so for the most part, we'll stick with flat yield curves, which are constant interest rates. However, what can we read about economic expectations? It's a little uncertain, right? They're not. The market here is showing some uncertainty and low confidence. They don't know whether to expect normal conditions or recessions in the short term. Both seem likely. What's maybe going on is some investors expect a recession and some don't, and they're maybe canceling each other out. It's hard to say. So it's a little more indeterminate, right, as opposed to a normal or an inverted yield curve. Right? The market's not all speaking with one voice. So that concludes this activity. The last thing I'd like you to do, and I'm going to put it into Canvas as a separate video, is watch this Vox video about inverted yield curves. It'll say a little bit more about how to understand what the bond markets are signaling in terms of their expectations. And by the way, they are generating yield curves from coupon bonds. We're going to do that in the next activity, although not in the next video. But we'll get to that. There's a method called bootstrapping that we'll do. Don't let that bother you. You can just ignore the fact that they're talking about coupon bonds and pretend you're dealing with zero coupon bonds, and you'll get exactly the right message out of the video. Right. So I hope that video is interesting, and I'll see you on the other side, and we'll start the next activity, which is about how to manage coupon bonds with a yield curve.